Okay, here we go. 3-6, rational functions. These are the form P of X over Q of X, where P and Q are polynomials. So they're ratios of polynomials. When we set X equal to 0, we get R at 0, P of 0 over Q of 0, that's the y-intercept. If P of C equals 0, so that's the y-intercept. The x-intercept is when P of C equals 0. So that'll happen when R of C equals 0. Okay. So that'll be an x-intercept. Actually, I'm a little bit concerned about this. This is really more like C by 0. This is a mistake. Let me note that down. 3-6 on C by 0. My apologies. Okay, we proceed. Okay, here's a very simple rational function, 1 over x. There's a peculiarity that when x approaches 0, 1 over x approaches infinity. So you get what's called a vertical asymptote. And also, when x approaches infinity, 1 over x approaches 0. So you get this, which is called a horizontal asymptote. It's sort of like when x is infinity or when y is infinity. So vertical asymptote is where x approaches infinity when y approaches infinity. Horizontal asymptote is when y approaches 0 when x approaches infinity. Well, actually, again, that's not strictly the case. That's the case in this case, but in other cases, it'll be y approaches some other finite limit. Okay, now, if we have a rational function equals P of X over Q of X, and Q of C equals 0, then X equals U as a vertical asymptote, because you're dividing by 0 and getting infinity. If R of X equals a polynomial with leading term a n x to the n over a polynomial with leading term b m x to the n, then its horizontal asymptote goes depends on a and b and n and m. So the idea is that horizontal asymptote asks what happens when x is very large. If n is less than m, then this grows faster than this does near infinity, and the whole thing approaches 0, y equals 0. If n is bigger than m, then a n x to the n grows faster than b n x to the n, and the whole thing grows to infinity, so there is no horizontal asymptote. If n equals m, if these are the same power, then basically these are the leading terms and everything else can be ignored near infinity, and just get a n over, well, bn. So for example, find intercepts and asymptotes for 2x minus 3 over x minus 2. Well, all right, the y-intercept, well, you plug in 0 and get minus 3 over minus 2. That's 3/2. Simple enough. That's the y-intercept. The x-intercept is when the polynomial, when the function equals 0. That will happen when the numerator is 0. 2x minus 3 is 0. So after a bit of algebra, that's x equals 3/2. The vertical asymptote is when the denominator goes to 0. So it's x minus 2 equals 0, so x equals 2 is the vertical asymptote. And then there's a question of, so we now know what happened when x is 0, or y is 0, or y is infinity. Now x is infinity, or approaches infinity. What we do is take the expression and divide numerator and denominator by the leading power, in this case, x. Here you get 2 minus 3 over x over 1 minus 2 over x. As x approaches infinity, this 3 over x and 2 over x approaches 0, and all we're left with is 2 over 1, which is 2. So y equals 2 is the horizontal asymptote. Now let's try this for this. Find the intercepts and the asymptotes for the function x minus 1 over x minus 4. Okay, the y-intercept is when x is 0. So r at 0 is 0 minus 1 over 0 plus 4 is 1 minus a quarter. 0 minus a quarter is the y-intercept. The x-intercept is when y equals 0. R of x equals 0 means the numerator is 0. X minus 1 is 0, or x equals 1. So 1 by 0 is the x-intercept. The vertical asymptote is when the function hits infinity. That happens when the denominator equals 0, x plus 4 equals 0, or x equals -4. So x equals -4 is the vertical asymptote. Straight line, vertical, which line the curve approaches but never touches. And now for the horizontal asymptote, we look at what happens for large x as x approaches infinity. So function is x minus 1 over x minus 4. Well, basically the leading terms dominate. So we did not divide numerator and denominator by the highest power of x, in this case x. You get 1 minus 1 over x over 1 minus 4 over x. Is the 1 over x and the 4 over x approach 0 near infinity, so you're left with 1 over 1, which is 1. So y equals 1 is the horizontal asymptote. You have a graph, identify the asymptotes. Here, there's one vertical asymptote, but y equals -2. Here's another vertical asymptote, but y equals +2. And the horizontal asymptote is this one, where y equals +1. Now here we have a complicated expression, find vertical and horizontal asymptotes. Okay, the vertical asymptote was when s equals infinity. Well, that's when the denominator is 0. So 3x minus 1 times x plus 2 equals 0. But okay, already it's all factored out, so that's easy enough. Either 3x minus 1 is 0 or x plus 2 is 0. And okay, this was when x is a third or when x equals -2. Those are the vertical asymptotes. As for the horizontal asymptotes, well, first we'll expand this out, this expression out by multiplying. 5x squared plus 4x minus 1 over 3x squared plus 5x minus 2. And this 5x squared and the 3x squared are the dominant terms when x is near infinity. So the one algebraic trick is to divide numerator and denominator by x squared. So it's to eliminate as many factors of powers of x as possible in both numerator and denominator. You get 5 plus 4 over x minus 1 over x squared, that over 3 plus 5 over x minus 2 over x squared. Near infinity, all this over x and over x squared terms approach 0, so left with 5/3, and that's y equals 5/3 is the horizontal asymptote. Okay, same question, intercepts, asymptotes, and the graph now. 4 minus 3x over x plus 7. So finding intercepts and asymptotes, it's sort of like finding points, and it's sort of like finding points on a curve, only asymptotes are where it fails to be a point at all. Okay, so s at 0, that's easy enough. 4 minus 0 over 0 plus 7 is 4/7. 0 by 4/7, that's the y-intercept. X-intercept is where s is 0, so the numerator must be 0. 4 minus 3x is 0. After a bit, that's 4/3 for x. 4/3 by 0 is the x-intercept. S is infinity when the denominator is 0. So that's x plus 7 equals 0, so x is -7. That's the vertical asymptote. Now, for the horizontal asymptote, we let x approach infinity. 4 minus 3x over x plus 7. We'll divide numerator and denominator by x. So you get 4 over x minus 3 over 1 plus 7 over x. The 4 over x and the 7 over x vanish near infinity, so you're left with -3 over 1, which is -3. So y equals -3 is the horizontal asymptote. And then it helps a bit if you do a sine graph when x is 4/3 or -7. Well, when x is 4/3, it's 0. When x is -7, it's infinity. And by comparing numerator and denominator, above 4/3, it's negative. Between 4/3 and -7, it's positive. Below -7, it's negative. So watch out, from here it goes from plus to minus through an infinity. So here we have a graph. We draw the line y equals -3 here. Is that right? Yes. We draw the line x equals -7 there. Those are the asymptotes. Here are two intercepts. 0 by 4/7, 4/3 by 0. It's going to be positive. It's going to be negative above 4/3, so it's going below 0 to the asymptote here. Here it's positive, approaching infinity for the vertical asymptote here. Below -7, it's negative, so it's below 0, and in fact, below -3, so it goes like this. Here's the graph. Okay,